multiplying and dividing radical expressions. I'm doing rationals in my other classes. All right, so let's look at this example right here, and there should be a time symbol right there. All right, so the deal is with multiplying, they have to be the same type of root. So you don't have to have the same number under the root. You just have to, you can only multiply square root, so you can't multiply square root with cube root, okay? They do not have to have, it's just like with fractions, they don't have to have anything in common other than they have to be the right kind of root. So if we have something like this, we multiply the coefficients in front. So 2 times 5 is 10, and we multiply what's under the square root. So 6 times 12 is 72. Then we need to simplify 72. 72 is 36 times 2, so that's 10 times 6, because the square root of 36 is 6, so that gives us 60 square roots of 2. Now, you may be looking at the beginning of the problem, and you may be saying, well, can't we simplify the square root of 12? You can, all right? It doesn't matter whether you simplify at the beginning or simplify at the end. Anywhere there's simplifying to be done, you can do the simplification. So here we get 20 square roots of 18, and then 18 is 9 times 2. Okay, so you get the same conclusion, you just simplify it in different places. Okay, so we're just multiplying what's in front, multiplying what's underneath, and simplifying. So again, with b, as long as those are both cube roots, we can do this. So negative 5 times negative 4 is positive 20. The cube root of 4 times 6 is 24. 24 is 8 times 3. The cube root of 8 is 2. 3 is not a perfect cube, so it stays. So that's 40 cube roots of 3. Now, let's switch it up a bit. Those were just monomials. Okay, those were just a single root times a single root. What happens when we multiply a binomial and a binomial? What do we have to do? We have to FOIL. Okay, it doesn't matter that there are any variables. Okay, we're just used to there being variables, but in this case we just don't have any variables. But it's still 2 terms times 2 terms, so we have to FOIL. Okay, we have to FOIL it. All right, so first times first. 2 square roots of 3 times the square root of 4 is 2 square roots of 12. Outside, 2 square roots of 3 times the square root of 2 is 2 square roots of 6. Inside, negative square root of 6 times the square root of 4 is the negative square root of 24. And negative square root of 6 times positive square root of 2 is negative square root of 12. Now, if you want to, you can go ahead and combine those square roots of 12. Or you can go ahead and just simplify all the square roots. It really doesn't matter. You can do it either way. So let's go ahead and put them together. Why not? 2 square roots of 12 minus the square root of 12 is a single square root of 12. Can we simplify the square root of 6? No. Can we simplify the square root of 24? Yes. It's divisible by 4. Yeah. So that gives us 2 square roots of 6. So those do cancel out. But we do have one more thing to do because we can simplify the square root of 12 into 2 square roots of 3. Again, use your calculator to confirm. It's a super easy thing to do, and y'all won't do it, and you make silly mistakes, and you don't check them. You don't catch them because you don't check them. How you like that one? Now, how could I have saved myself just a little bit of work in this problem? Is there any simplifying I could have done at the very, very beginning? How about the square root of 4 is 2? You know, I mean, it worked out, but I'm just saying, if you see a perfect square in there, go ahead and simplify it. Okay, go ahead and simplify it. All right, let's look at D. 7 plus 5 square roots of 2 times 7 minus 5 square roots of 2. Does anybody know what we call those two expressions there? Besides binomials, they have more specific names. Conjugates. Does that word sound familiar at all? Have you ever heard that before? Okay. A conjugate means it's the exact same expression, but they have opposite signs. Okay. It's the exact same binomial expression, but they have opposite signs in between them. Okay. So let's see what happens when we multiply these conjugates right here. 7 times 7 is 49. 7 times negative 5 square roots of 2 is negative 35 square roots of 2. Inside, 7 times positive 5 square roots of 2 is positive 35 square roots of 2. And then positive times a negative is a negative. 5 times 5 is 25. What's the square root of 2 times the square root of 2? 2. The square root of 4, which is 2. All right, so those square roots of 2 in the very middle cancel each other out because we've got negative 35 and we've got positive 35. Those cancel. So we've got 49 minus 25 times 2 is 50. So this whole expression right here is just equal to negative 1. Who would have thought when we started that problem they would equal negative 1? Now, the lucky thing is your calculator would actually work this one out for you because it ends up, it's not a square root. Okay, so now, not all conjugates, when you multiply them, do you get negative 1. All right, not all conjugates, when you multiply them, do you get negative 1. But when you multiply conjugates with square roots, guess what? The square roots do always cancel out. If they don't cancel out, then you didn't multiply something correctly, or they're not conjugates. Okay, but when you have the exact same radical expression, one's got a plus, one's got a minus, it's going to give you a whole number answer. Okay, so practice.